Okay, in this class I want to just revisit friction based on a couple of questions I got really during the week. On Teams I want to go over some of these, just a few little things on friction, because it is important to understand before you move forward. So here I have a particle on a horizontal plane, and what I want to do is I want to complete the force diagram. I've got a tension force here pulling to the right of 10 newtons. I've got a weight force here pulling down of 500 newtons. So the weight of the object is 500 newtons, and I want to complete the force diagram. That's the question, complete the force diagram. So I have to think about the other forces that are involved. Notice I'm given a coefficient of friction, so I can see it's a rough plane, so there's going to be some kind of friction. Let me put in force vector arrows for the other two forces, so we're going to have some force acting up. Anytime two objects are in contact, there's a contact force. This is called the normal reaction, which is or in this case. We'll come back to that in a moment. And then there's going to be some friction force, which I'm just going to give the letter F to. So we've got the friction force. So there's four forces at work on this particle. There is its weight downwards, tension force pulling it to the right. There's a normal reaction, which is the force on the particle by the horizontal plane. And then there's the friction force, the force on the object by friction. And we want to work these things out. Now notice it's on a horizontal plane, so it's going to be traveling horizontally, which means there's going to be no acceleration downwards or upwards, which means the force is up must equal to the force is down, which means of course the normal reaction, which is the force up, has to equal to the force down, which is 500. Okay, newtons. I'll just put in units for the moment. The next thing I want to think about is this friction force, the coefficient of friction, which is 1/5, and I want to think about this friction force. So what is the friction force? Well, the first thing I'm going to think about is what is the maximum possible value of the friction force. And the maximum value of friction force can reach is defined as being mu or. Okay. In this case, mu is 1/5, and the normal reaction is 500. So friction can reach up to 100 newtons. It's possible that friction could be 100 newtons. Another thing to remember about friction is it doesn't really create motion. It prevents motion, it's fighting motion, but it's not going to create motion. So I want to think about this friction force here. Well, if I thought of it as being 100, well then we would have a force to the left of 100 and a tension force to the right of 10, which would mean this would accelerate to the left. It doesn't make any sense. All friction does is it matches tension, it matches the opposing force, the force is trying to move it, for as long as it can. So in this case, friction is going to match tension as much as it can. And the question, I suppose, is can friction match the tension force here? Well, friction can get up to 100 newtons, so can friction match this 10 newtons of force? Well, absolutely it can match that 10 newtons of force. So in this case, the friction is going to be 10 newtons. What's going to happen to this object? Well, assuming it was at rest at first, it's going to remain at rest. If it was in motion horizontally, it will continue in motion horizontally, but without acceleration. There's going to be no acceleration because there is no net force. So no net force, that means there's no acceleration. So this object is not going to accelerate at all. Okay. Note the friction. This is something I see correcting work quite often. People will just go and stick in 100 newtons there. It wouldn't make sense in this case for friction to be 100 newtons. It's able to match the 10. In fact, it can match anything up to 100. Beyond that, it can't match it anymore. So in order to create motion, I have to kind of outweigh friction. Almost identical, except that tension force has increased here. So I want to complete the force diagram. And again, let me go straight in here. It's just like before. The only thing that's changed is this tension force pulling to the right. So we're going to have our normal reaction here, which is again going to be that 500 newtons of force. And I'm going to have some friction force pulling to the left. I want to think about that friction force. What is the maximum value that friction force can reach? Well, friction can reach up to mu times the normal reaction. Mu is a fifth, the normal reaction is 500, so mu can get up to, friction can get up to 100 newtons. That's its maximum value. That's what friction can make it up to. Okay, in order to prevent motion, friction can reach up to 100 newtons of force. So what is the friction force here? Well, the tension force that's trying to create motion to the right is 20 newtons. Can friction match it? Yes, it can, because friction can reach 100 newtons. But it doesn't need to reach 100 newtons in this case. It only needs to reach 20. So the friction force in this case would be 20 newtons. If I increase the tension force by pulling harder on this string, well, then I will increase the friction force too. Suppose tension is 30 newtons, almost the same setup. Upwards, we have a normal reaction. Again, I'm going to just say, we've looked at this already, the up forces are going to equal the down forces because it's moving on a horizontal plane. So that's 500 newtons, and we're going to have this friction force out here to the left. What can it be? Well, we've looked at this example already. The maximum possible value for friction is mu, 1/5, times the normal reaction, which is 100. So friction can get up to 100. Does it need to get up to 100 here? No, it only needs to get up to 30. So in this case, friction would be 30 newtons. Suppose I want to find the least value of t for acceleration to occur within this system. So to find the least value of t for acceleration to occur, again, same system, we've got a particle on a horizontal plane. Again, the up force is going to equal to down forces. The only upward force is that contact force between the plane and the particle, the force on the particle by the plane. We call that the normal reaction, and that's going to be equal to the downward force, which is 500 newtons. Just like before, the maximum possible value for friction, well, it's mu times or 1/5 of 500, that's 100 newtons. So friction can get up to 100 newtons. So in order for acceleration to occur, we have to outweigh friction. In other words, we have to pull on this string to the right so that we create a friction of 100. So we get friction. Friction would have to be at its maximum value in order for acceleration to occur. So in order for acceleration to occur, the tension would have to be bigger than 100 newtons. So to create motion in this particle through pulling on this string to the right, we would have to have a tension force in the string of 100 newtons. Okay, in my next lesson I'll look at throwing in a few awkward angles in there, but same kind of concept.